Good evening. It is 6 p.m. Let's read some more. I have to keep reading or I will never be finished. I will never be finished reading anything. So just follow my list. So just follow this list. I think I have to do my camcorder a little bit more level. Good. So let's read.
Planar process. The planar process is a manufacturing process used in the semiconductor industry to build individual components of a transistor, and in turn, connect those transistors together. It is the primary process by which silicon integrated circuit chips are built, and it is the most commonly used method of producing junctions during the manufacture of semiconductor devices. The process utilizes the surface passivation and thermal oxidation methods. The planar process was developed at Fairchild Semiconductor in 1959. The planar process proved to be one of the most important single advances in semiconductor technology. Overview, edit. The key concept is to view a circuit in its two-dimensional projection, a plane, thus allowing the use of photographic processing concepts such as film negatives to mask the projection of light-exposed chemicals. This allows the use of a series of exposures on a substrate, silicon, to create silicon oxide, insulators, or doped regions, conductors. Together with the use of metallization, and the concepts of p-n junction isolation and surface passivation, it is possible to create circuits on a single silicon crystal slice, a wafer, from a monocrystalline silicon boule. The process involves the basic procedures of silicon dioxide, SiO2, oxidation, SiO2 etching and heat diffusion. The final steps involves oxidizing the entire wafer with an SiO2 layer, etching contact vias to the transistors, and depositing a covering metal layer over the oxide, thus connecting the transistors without manually wiring them together. History, edit. Development, edit. At a 1958 Electrochemical Society meeting, Mohammed Attallah presented a paper about the surface passivation of p-n junctions by thermal oxidation, based on his 1957 BTL memos. Swiss engineer Jean Huerny, one of the traitorous eight, attended the same 1958 meeting, and was intrigued by Attallah's presentation. Huerny came up with the planar idea one morning while thinking about Attallah's device. Taking advantage of silicon dioxide's passivating effect on the silicon surface, Huerny proposed to make transistors that were protected by a layer of silicon dioxide. This led to the first successful product implementation of the Attallah silicon transistor passivation technique by thermal oxide. Jean Huerny, while working at Fairchild Semiconductor, had first patented the planar process in 1959. Together with the use of metallization, to join together the integrated circuits, and the concept of p-n junction isolation, from Kurt Lehoveck, The researchers at Fairchild were able to create circuits on a single silicon crystal slice, a wafer, from a monocrystalline silicon boule. In 1959, Robert Noyce built on Huerny's work with his conception of an integrated circuit, IC, which added a layer of metal to the top of Huerny's basic structure to connect different components, such as transistors, capacitors, or resistors, located on the same piece of silicon. The planar process provided a powerful way of implementing an integrated circuit that was superior to earlier conceptions of the integrated circuit. Noyce's invention was the first monolithic IC chip. Early versions of the planar process used a photolithography process using near-ultraviolet light from a mercury vapor lamp. As of 2011, small features are typically made with 193 nm deep UV lithography. As of 2022, the ASML NXE platform uses 13.5 nm extreme ultraviolet EUV light, generated by a tin-based plasma source, as part of the extreme ultraviolet lithography process. See also, edit. 1 Semiconductor device fabrication. References, edit.